Cheers. So I used to believe the same thing everyone else does, that more screen equals more observability. And if I could just see enough metrics in enough places, I wouldn't get pulled out of a flow state when I work, or get stuck, or get surprised. But that's not always true. And I've become suspicious of something, being that large wall screen displays are not there to help engineers solve incidents. And of course, during the pandemic, many of us learned to work from home without any of these things, and they've become a bit of a moot point. And in many cases, they're just there to make management feel comfortable or to impress visitors. And no engineer wants to be bothered by a manager coming over and asking, why is this red? So we have this unspoken agreement where we're going to keep all the pretty dashboards up on the walls, and we're going to keep the good dashboards for ourselves, even if they're ugly. So why, when you look at any of these operation centers, no one is looking up at the wall displays? They've become more like project or system status art at this point for me. And besides, wall displays work against how the human eye has evolved to work. Your awareness or perception these days isn't different to how it came and evolved when we still looked out over the plains or jungles. And this comes from the way your eye works with these very quick little rapid eye movements called saccades. It's amongst the fastest movements your eye can make at 700 degrees per second. And you use them when you're trying to do something like trying to find food or trying to escape a predator. And it makes up only 2% of your entire field of view. And that's because your retina has a small little spot on the back called the fovea, which is very densely packed with these special cone cells. So densely that there's a non-linear drop-off in the ability for you to perceive any detail beyond that space because of this tiny little spot that makes up only 0.16% of your entire retina. So that's about the size of your thumb if you hold that up, just the size of your thumbnail, or the moon in the night sky. So what happens is, as you're perceiving these small little saccades every 100 couple of milliseconds, your brain is using 50% of your visual cortex to process only 2%, or rather 2 degrees, of your field of view. So if you wanted to create a loosely coupled model of how the brain works inside as a computational model, you could think of your awareness as a frame buffer that only gets updated with 2 degrees of what you can see every clock cycle. And not everyone has a job where they're going to watch dashboards change all the time. We're expected to work on the systems that we're evolving and setting up and building new features, etc. And then we get slammed with an alert, and we get this rush of adrenaline. We're pulled out of a flow state, and we replace productivity with cortisol, and you're sometimes stuck in this freeze, fight or flight response. So then you open up a browser, and if you did put the dashboard into a bookmark, then that worked out pretty well. But then you still need to go search for it, or you give up and you just SSH into the server and you tail out the logs. So this is where I want to hack the model. If your foveal vision only gives you 2 degrees and your central vision is 60, your peripheral vision gives you more looking down than up. And that explains why you're more likely to notice something on your desk than you are to notice something up on a wall display. And that's exactly where we hack the model. So your peripheral vision is wide but low detail. Detection happens before awareness, and your peripheral vision is wired to only work on motion, sudden changes, and contrast differences. That's why your phone sitting on your desk or on your lap right now can grab your attention, and that's what I want to put to better use. I want to reduce your mean time to detection, if that's something important to you, and reduce the number of interruptions and stress that you experience. And I've done so by stealing something from Twitch streamers. Now, a Stream Deck is just a programmable macro pad that you can use to control all kinds of things, launch apps, programs, etc. And my interest in it came from productivity hacking. And it's become quite a mature platform at this point. They've been around for many years. They even have a foot pedal. And it's no coincidence that the size of those little 72 pixel by 72 pixel screens on those buttons are the size of your thumbnail. So to that end, just a disclosure, they are manufactured by Elgato. I do not work for Elgato. They didn't pay me. They didn't give me any hardware. I wish they did. But they do have a really nice to work with developer program. And I want to give a big shout out to Stephanie and Zach from the Elgato marketplace who set all these things up. You can download hundreds, maybe even thousands by this point, of different apps to use on this kind of device. But when I first got one, I looked for a Grafana app that I could use, and there wasn't one. So what I've done is hack together a small little way of putting at least stats and gauge controls onto the Stream Deck so they're always in your peripheral vision and you notice them. Now, I've done this with what I've now learned is the soon-to-be deprecated V1 HTTP API of Grafana's. And I've done, now while all these apps are DRM protected and managed well by Elgato themselves, I've taken an extra step to scrub any tokens that you might use, and I've added some additional encryption. You can go check out some of those things on the GitHub repository. There'll be a QR code at the end of this talk. And the way you set this up, one pro is nothing that Elgato writes comes in light mode. I see that's important to this audience. But anyway, all you need to do is set up a service account, preferably a read-only one always, and then you pop that into the Elgato software that controls your Stream Deck. And then from there, you can select, it uses the API to pull out the existing dashboards and different controls. It'll only pick up your gauge and stat controls, and from that point on, you can just choose whichever panel you want, and then it's up and running. There's also the ability to, from manual controls, be able to shorten some of the names just for the version you've put on your Stream Deck. And then in a few minutes, you can have something like this. Now, in all fairness, all of this can be done with a Raspberry Pi and a nice touch screen in kiosk mode, or on a phone with some free software. You could, if you're a maker, you can make something with an Arduino. And I love the Raspberry Pi, but if one's sitting on my desk, I'm going to plug it into something else and use it as a server or something like that. So I prefer using something that is more professional, sits on my desk, and makes me look cool. One other feature that you just saw happening there is whenever you have a metric that's not behaving the way you want, you can tap on it, and it opens up that specific Grafana dashboard where you can see exactly what's happening, although it's not practical to maybe have so many controls over a big Stream Deck. What you typically want to follow is something called Miller's Law, which is the idea you want maybe 5 to 7 controls. You're not overwhelmed by everything on there. And you only want to be able to monitor signals that let you know that something's not right, something needs to be addressed, and you want to go look into that with some more detail. And of course, if it's going to be very costly for you to not notice that something is starting to go wrong, this is a good approach to follow as well. So I want to take everyone out of this experience where you suffer this alert and you get this adrenaline spike, and then you have to run and scramble, more to a place where you can pick up a trend out of the corner of your eye, and you get curious about something and you can begin investigating. Another cool thing I really enjoy is all of you have been on these calls late at night where something's gone wrong and everyone's unhappy. There's nothing like being able to quote real-time changes in stats without breaking eye contact from the camera. And there have been other attempts at putting things in people's peripheral vision. Now, the MacBook Touch Bar didn't work out, and I know it wasn't exactly designed for this. But it's not a perfect model. And certainly when we experience any of these big outages, you can get this perceptual narrowing or tunnel vision where you get stuck in your idea of what you want to do or what you need to do, and are you following the correct path? Interestingly, police are trained to deal with high-stress situations by forcing saccades and moving their heads around. They practice this and practice this. Did you notice that the assailant in this case has already dropped their gun? Now, some of you may also argue that I've not been trained like a police officer or someone to do this kind of thing. Most of you probably drive, but not everyone's used to checking their speed. Few of us are flying planes or even fighter pilots with cool heads-up displays or anything else like that. But I'd like to argue that all of you, in one way or another, have been training to do this your entire lives. Many of you started early. And if you're picking up the trend, you're used to focusing on something where you're in a fight, but you're still tracking things, and you know when to break off, go grab ammo or health points or whatever else you need. So if you saw the pattern, I'd argue that you're ready. Thank you very much. Everything is up on GitHub if you want to play with that. And I'm going to hand it back to Matt.